In Chapter 10, we're going to go deeper into Spring support for SOAP. Spring WS is a plugin for Spring that adds more SOAP functions. The first and probably most important thing to do is to answer the question, what is Spring WS? And why is an additional plugin library necessary? The quick answer is that Spring WS is designed to support a technique called contract-first development, and full details will follow. Part of contract-first development is that you can take full control of the XML messages. To do that, we're going to use a library called JDOM. I have to warn you, there will be a lot of XML manipulation in this chapter, and it can be quite hard going. It is a long chapter at about 80 minutes, and I just couldn't find a natural break point. But of course, you can always pause at any point. In the previous chapters on web services, we've been concentrating on JAX WS, which you know now is the built-in Java library that aims to make the construction of web services simpler. In short, the strategy is that with JAX WS, we take an existing Java class, we point JAX WS at it by adding the web service annotation, and then JAX WS will generate the entirety of the WSDL for us. Also, it hides any visibility that we have of the underlying XML messages. We've been working so far with just regular Java methods. We've never really felt that there's any XML underpinning the whole process. And for many people, this sounds like a great idea. It is relatively simple, and let's face it, not too many of us want to deal with XML. But there are some problems with this approach. Now, don't get me wrong, JAX WS does work, and many projects use it, and I have successfully used it in the field. But there are problems. Now, the first problem is that Java and XML are just not the same. They were designed by different groups of people at different times, and they have very different design decisions in them. So although it sounded like a very good idea that we can use JAX WS to look at any method that we write, such as get customers here, and automatically generate an XML schema from it, might sound like a good idea, but that's only really going to work if the types that you're working with are simple. And I have to admit that in the previous chapters, I was very careful to only use relatively simple types of data. Our methods, for example, were returning lists of customers. That's quite easy to do in XML. But imagine that you have a method such as the method here, getCustomers, which in this case is returning a map of keys and values. Now, of course, in Java, maps are really common. But what is JAX WS going to do in converting that into an XML document? Well, the answer is it can handle it, but there's no standard way of representing a map in XML. The example I've come up with here is just a little sketch that I did a few moments ago, and it's just one of many different ways of representing maps. So this means that the XML that we're going to be returning from this web service is potentially non-standard and will cause our clients to have terrible problems in working with our web service. The second problem is the generation of the WSDL. If we're going to hand over control of the complete generation of the WSDL to a tool, then we're not going to get any kind of fine-grained control over what appears in that WSDL. Now, you might think that's a great idea because writing WSDLs is unpleasant. But in a web service, the WSDL is the most important element of the entire web service. It's what the clients are going to use to access our web service. And if we're just going to automatically generate that WSDL, we're going to find that the WSDL is far from perfect in many cases. Just a quick example. Here's the WSDL that we generated in the previous chapter for our entire customer management service. If we focus in here on the XSD section, in fact, the generated WSDL has a separate file where, and I'll just copy and paste the URL of that separate file, and this is the file where all of the types are defined, such as, for example, our customer type here. So all of that was generated automatically by JAX-WS, and it did that by looking at our Java class. But we can do much cleverer things in a WSDL than we can sometimes do in Java. Let's say, for example, on our project that customer IDs have a particular format. Let's say that the customer IDs must be exactly 5 numbers. No more, no less. There can't be letters appearing in the number. It has to be exactly 5 digits. The Java data type that we've been using has always been a string. Now, we might be validating that string in our Java, but at the moment, a client looking at this WSDL has no real clue what the format of this customer ID needs to be. It looks like the string, which is the current type here, can be any string of characters. But WSDLs can be far richer. If we were writing this WSDL by hand, we could have specified that the customer ID must match a particular regex pattern. In a WSDL that we'd written by hand, we could have done something like this. So a WSDL supports very complex and rich types. Actually, it's not really the WSDL, it's the XSDs that we're writing as part of that WSDL. If you've never seen these special types before, then it looks something like this. We can specify in the WSDL or the XSD that we have a new type called customer ID type, which is based on a string, but it must be exactly 5 characters in length, and for each of those characters, the characters must be the characters 0 through to 9. This is a standard regular expression, and if you're familiar with regular expressions, then you can get very sophisticated with the patterns that you can specify. So it would be great if we could have added that to our WSDL, but because it was generated, the generator could only work with the basic raw Java types that it saw. So it really depends on your project. If it is the case that you're happy to just allow a Java tool to automatically generate this WSDL and schema description, and if you're happy for it to have some possibly rough edges as a result of that generation, then JAX-WS is fine. But many projects want to have complete control over this WSDL. They want to be able to write it for themselves. Now, in web services jargon, the approach of writing the WSDL manually yourself is called contract-first web service development. Now, to put this another way, this means that you should start with the WSDL and write it completely fresh by hand. This way you can give full attention to what the contents of the WSDL should be and exactly what data the client should be sending you. Now, don't be misled by the term contract first. Some people think that with contract first, the WSDL needs to be absolutely the first thing that you write on your project. But I don't think that's what it really means. It means that when we come to set up the web service part of our application, we will treat the contract, in other words, the WSDL, as being the most important thing. We're going to be, if you like, putting it first in the hierarchy of the artifacts that we're developing. To use as an example the application that we're building, we've already written the Java, we've already implemented the entirety of our customer management service, but we can still do a contract-first web service. So what we're going to do in this chapter is we're going to ignore the code that we've written so far, and we're going to say, okay, what do we want to expose to our clients? What should the operations be called in the WSDL? And what data do our clients want to send and receive? In other words, we're going to design the WSDL almost from scratch, and we won't necessarily make it a carbon copy as the code on our server. So the focus of this chapter is how to write these contract-first web services. But of course, the other focus of the chapter is the tool that we have to do this, and it's called Spring WS. Now, I think if you find this chapter heavy, and it's certainly one of the most advanced chapters on this course, I think the one key thing to learn is what Spring WS actually is. I think it's really confusing because it's quite badly named. Spring WS doesn't really tell you very much, and it's very easy to get Spring WS confused with what we've been doing in the earlier chapters. Let me try to be as clear as I possibly can. The built-in Spring support for web services, the support that we've been using on this course so far, is all based on JAX WS. So that's everything that we've done so far. Now, if you decide that you want to go down the contract first route, then you're not going to be using JAX WS anymore. So that means, effectively, that there is no built-in support in Spring for contract-first web services. That's why there is a separate project, and that's a key thing. Spring WS is a separate Spring project. You're probably aware as a Spring developer that there are some sub-projects, kind of third-party projects, but projects very closely aligned to Spring. It's not part of the core jar files that you've been working with so far. You'll be going to another website and downloading a new set of jar files to make this active. But as I say, I don't like the name Spring WS because that suggests it's Spring Web Services. But really, Spring WS is a project that exists specifically to allow you to write contract-first web services. Now, you are going to be doing a lot more work by hand when you're doing contract first, but we still need some support. We're going to need some support to allow us to write the endpoints and to allow us to expose those handwritten WSDLs. So you'll be seeing over the course of this chapter what Spring WS does for you, but I want to absolutely emphasize that Spring WS is only for contract first web services. If you're happy to work with the auto generation that we've seen that JAX WS supports, then you can continue with the built-in Spring Web Service support that we used before. Let's assume that you do want to go contract first. Then let's see how Spring WS works. As usual, I've supplied you with the jar files that you need for Spring WS, and I'll point you to those in a few moments. But I do need to show you where you would have found those jar files were you not doing the training course. Here I am on the current URL for the Spring framework. It's still spring.io. That may have changed by the time you watch this course because it keeps moving URLs. But anyway, if I follow the link to projects, currently at the top right here, there's Spring Framework. That's the standard core Spring framework. And if I go a little further down, here we are, Spring Web Services. But let me just re-emphasize what I said on the previous caption. Although that suggests that this is support for general web service development, it is specifically, as the sentence says here, for contract-first SOAP web services. So if I follow the link there, you'll find a link to the reference documentation here on the right-hand side. You are going to need that documentation because I won't be able to cover everything on this course. And just going a little further down, if you were using Maven, then the Maven dependency you need is right there. And just to review their high-level description of Spring WS, just to re-emphasize again, contract-first SOAP development, and it's really talking about how they believe that contract first is absolutely the best way to work in SOAP web services, and therefore if you're following best practices of developing web services, then you'll be using Spring WS. So if you find the folder for additional jars for this chapter on Spring WS, you'll find in there a small collection of jar files and an XSD file that I'll be coming on to later. It's the jar files we're interested in. And actually what we've got here are the Spring WS jars. There's 4 of those. There's the core, and there are further jars for security, support and testing. And we'll probably not be using all the functionality from these jar files in this chapter, but it's well worth getting all 4 of them for future work. There are then 3 supporting jar files. There's a Spring XML jar file, a WSDL4J jar file, and a QName jar file. They're just kind of helper jars that the main WS jar files are going to use. So that's 7 jar files, but there is an 8th jar file, and that's jdom.jar. Now, I'm be coming on to what jdom is in a few moments, but you only need that jar file if you're planning on working with jdom. So if you're working on a live project, then you may find that jar file switched for a different jar file, and I'll be explaining why shortly. But for the purposes of the training course, you'll be needing all 8 of those jar files. So I suggest you copy those into your lib directory, and then you'll only actually need the WS core jar file for the purposes of compilation. So I'll right click on that jar file, build path, and add to build path. All of the other jar files are just needed at deploy time. In other words, they're needed on the server, and I won't bother adding those to the build path. Now, because of course this course you don't have to do the chapters in order, I don't know what state your project is currently in, but in the previous chapter I did add quite a lot of extra jar files. I think it was 14 jar files to support using JAX-WS on the server. Now, it was rather tedious, but I've added those 14 jar files, and it was essentially the implementation of Metro. We don't need them for this chapter, and I'm feeling a little nervous about this number of jar files exploding. So I'm going to suggest that if you did the previous chapter, we're going to clean up the lib directory. So I strongly suggest that you go into your lib directory in your Package Explorer and highlight the following jar files. And all I'm doing here is just running through the jar files that are in the additional jars for the previous chapter. It was the gmbal jar, HA, API.jar, then all of the jar files beginning JAX-B, and then all of the jar files beginning JAX-WS, including JAX-WS Spring.jar. Then there was also the management API.jar file, policy.jar. There was also stacksex.jar, streambuffer.jar, and xbeanspring.jar. And I did that by control clicking, or if you're on a Macintosh, it will be command click. And then I'll just need to select any one of them with a right click and then delete, and just confirm there that we're deleting 14 jar files and click on OK. Now it is warning me that the jar files are being referenced by the project, or at least some of them are. So I'm going to say yes to all there, but then I will have ruined the build path for the project. So I'll right click on the project, build path, configure build path, and then on the libraries tab, for every one of these references with a red X there, I'm going to select and then click remove. So that's a little bit tedious, and those of you who are Maven fans or Gradle or whatever will be laughing right now. Life will be much simpler. And the red warning icon has gone away now, and everything is now building correctly. So we've now brought Spring WS into the project and removed the JAX-WS implementation that we were using before. So just to very quickly review what we had before with the JAX-WS version of our web service, the key class in the web service was this class called Customer Endpoint, which currently has an annotation of @webservice, and to check the import of that, that comes from the standard JAX-WS library. You recognize JAX-WS by the import you can see here. Now there's lots of WS's here. It's important to remember that this annotation is from JAX-WS and not from Spring. And then we had these methods, which were really just passing through to the underlying service class implementation. Now we're going to completely re-implement this now using the Spring WS approach. And really the Spring WS approach is a two-step approach. First of all, we're going to define our WSDL. We're going to write that by hand. And then in step 2, we're going to rework this endpoint so that this endpoint is working with true XML. So step 1 in the process then is writing the WSDL by hand. Now that will strike fear and dread into many developers, but remember this is the point of the exercise really, to give us complete control over what we're going to expose to our clients. Well, the first thing to say is actually we don't need to write the complete WSDL. A large part of the WSDL can still be generated. Really, the valuable part of the WSDL is the schema declaration. If I go back to our earlier WSDL that we were using on previous chapters, in fact, the really interesting part of the WSDL was this line here, where the schema declaration is imported. And you'll remember that the schema declaration, which I'm now showing, contains a definition of all of the types. And that means, for example, our data types, such as customer and call, but also our exceptions, and also, in fact, the messages that are going to and from the web service, such as find customer by ID and find customer by ID response. Well, in Spring WS, we can write the XSD and Spring WS will take care of the rest. If I go back to the WSDL, the rest of the WSDL is actually, if you pick through it, all fairly routine stuff. It's doing things such as building operations, which it's doing really just by gathering the types together. So we're going to have an operation, for example, called get all customers, which was one of the types in the XSD, and there will be a response called get all customers response. So we can ask Spring WS to generate this part of the WSDL for us, as long as we write the XSD, and actually it's there where all of the value lies. But even writing an XSD is not a particularly easy and straightforward process. Now, because this is a Spring course largely, and it's not an XML course, I've decided to give you a pre-written XSD. You'll find it in the Spring WS additional jars folder, and I've called it the CRM schema.xsd. If you just copy that file and paste it into your SRC folder, the SRC folder, by the way, is just a kind of convenient place to put it. You could put it in a folder of its own, but you would have to modify the build script to pick it up. So I'm just going to have it in the SRC folder. Now, although it's pre-written, I would like you to have at least a basic understanding of its contents. If you double click on it, depending on which version of Eclipse you're using, it might open this designer, which I don't find particularly intuitive. If you get this, click on the Source tab down here, and you'll get the raw XML. So I'm sure you know what an XSD is already, but if not, an XSD is a document that describes the valid content of an XML document. So for example, here, this is describing the valid structure of a customer XML record. So it's saying that I must have an opening tag called customer, and then inside there must be a sequence of elements. The elements are customer ID, company, email, and so on. And a sequence in an XSD means that each of these elements must appear once and once only in this order. However, you'll notice on the notes and phone record, I've decided to specify that the min occurs is 0 and the max occurs is 1. You can work out what that means. It means that notes and phone are going to be optional. Its minimum occurrence is 0 and its maximum is 1. If you don't specify min occurs and max occurs, then the default is 1 for both. That's why customer ID, company name, and email are going to take the defaults and therefore will be mandatory. So here already is a good example of where I've been much more creative in the XSD. When this was generated previously, the generator wouldn't dream of adding constraints like this. So that's quite powerful. Similarly, if you have a look at the type here for the customer ID, I've defined this as being the customer ID type. The customer ID type is defined here in this block, and it's what I showed you on the previous caption. As I mentioned, I would like it to be exactly 5 characters long, and each of those characters is just the digits 0 through to 9. So as well as defining the actual types of data, we've also got to create the types for the inputs and outputs to our web service. So for example, we're going to have a get customer by ID request type. And although I've had to use sequence here, there's only one element in that sequence, which is going to be the ID. So get customer by ID, I've decided is going to take an ID, and it's going to return, by way of the response, a customer element. So I hope that's fairly understandable. If you'd have to write this by hand, it can be a little bit painful. It did take me well over an hour to write this XSD, I must admit, and I had quite a few errors at my first attempt. I must point out, though, that because we're going to generate the WSDL from this, the default assumption of the generator is that any type ending in request needs to become an operation, and any type ending in response needs to be a return from an operation. So that's why you must have request and response here. If that's not the case, then it's not really a big deal because you could write the full WSDL by hand, which, to be honest, is not a lot harder than writing this XSD. But I'm happy to go with these defaults for now. Now, as I said, I want to avoid XML as much as possible on this course, or at least going into detail on XML. Frankly, if you decide to go down the contract first route, then you're going to need someone on your project that really understands XML deeply. But I think the hardest part of XML is working with namespaces. Now, much as I'd like to avoid talking about namespaces, we are going to have to reference them in the code. So a very brief overview of what a namespace is all about. What we're effectively doing with this document is we're defining the structure of, for example, a customer in our business. Now, the problem with defining XML tags such as customer and company name is that there's a potential for those tags to clash with other tags in other documents when we combine documents together. Now, I don't know how much experience you've had of combining XML documents together, but effectively that's what's going to be happening when we work with SOAP. In the WSDL, for example, is composed of lots of different tags coming from lots of different XSD descriptions. Now, to avoid the possibility of any name that we use here clashing with a name used in another XML document definition, we use a namespace. And a namespace really is just a unique label that we associate with our XSD. So, for example, our namespace here is virtualpairprogrammers.com/CRM. We've given it this prefix here, TNS, which just stands for target namespace. And by prefixing, for example, the reference to customer here, the XML parser knows that the customer we're referring to there is our customer definition and not some other customer definition that might be in another XSD. Now, okay, the chances of a clash are relatively small. I doubt there are going to be any other customer definitions, but the potential is there, and that's what the namespace is for. Now, you might be confused about the namespace name here. Notice it has a HTTP : and so on in it. But really, all we're doing with a namespace is we're just choosing a string, almost an arbitrary string, that we are guessing is quite unique. Now, unless we use some kind of GUID here, we're not going to guarantee uniqueness, But the general idea is that if we use our company's domain name, usually with some project name appended to it, that's why I've put CRM here, we can pretty much guarantee that because we own this domain, if I then work with another project from another company and they give me their XSD, if they've used their domain name, then their namespace will be completely different to mine, and therefore we're never going to have a clash. So it's not exactly a guaranteed globally unique system of coming up with namespace names, but it makes things relatively unique. Now, of course, you're familiar with that kind of way of working because we do exactly the same thing with Java package names. By using our company domain name, any classes inside that package, we can kind of guarantee that the package that they live in has a unique name. It's just the same thing with XML namespaces. Now, the reason this is important is the namespace that we're using here, we will have to refer to in the code. I won't go into any more detail on namespaces, and I'm sorry if that description wasn't the best description of namespaces ever, but do remember that we have a namespace and it ends in /CRM. The next step is that we have to write a so-called endpoint. You'll be familiar with the endpoint from the previous work on JAX-WS, but really in JAX-WS the endpoint wasn't a very interesting class. All of the methods were largely just delegating to our business code. There wasn't much for the endpoint to do because by the time the endpoint's been invoked, JAX-WS has generated a Java object representing the incoming data. But when we're working in contract first, one of the advantages, if you like, is that we will have complete control over the XML so that we don't get any nasty surprises. This is particularly useful if you've got complex XML structures. So, although we didn't really think much about XML in previous chapters, remember that when a client, regardless of what that client is, Java, Visual Basic or whatever, when the client is invoking an operation, really it's sending an XML document across the wire. And our endpoint is going to receive that XML document. Because we're using Spring WS, our endpoint is effectively going to receive that raw XML. Well, actually, let's be more specific. The XML isn't just going to be a string containing the XML document. It's going to be more accurately a representation of the raw XML. Now, what do I mean by representation? Well, really, I mean it is still going to be a Java object. And we can choose what the representation is going to be. Now, there are lots of different frameworks in Java for working with XML. Some of those frameworks give you very low-level, fine-grained control over the XML processing. And some frameworks will automatically transform the XML into Java objects. There's a wide variety of these frameworks in Java, and Spring WS has decided to support many of them. So when we're writing this endpoint, we get a choice. We can, if we want, work with very raw XML and process each of the tags individually. That will give us complete control, but it will be tedious. Or, if we prefer, we can use one of the higher-level XML libraries. We can even ask Spring WS to generate a Java object based on the incoming XML. Now remember, that's exactly what we had in JAX-WS, generated objects. But the difference is here we get to choose. And it might be for a web service that for 8 out of the 10 operations on the web service, we'll use the automatic generation of objects. But for 2 of the operations, we need much finer grained control, so we'll work with a lower level API. And I think that's a key thing to get across about Spring WS. We get to choose on a method by method basis what strategy we use for processing that incoming XML. If you're interested in the different XML frameworks that are supported, you can go to the Spring WS homepage and find the link to the reference manual, and it's buried quite deep in the document, but at the time of recording, it's in Chapter 5, subsection 5.4.1. That may have changed by the time you look at this document, but the chapter title is called Endpoint Handling Methods. And if you scroll a little further down from there, there's a table. I'll just make the font a little smaller here. There's a table here showing you the different strategies we can use to handle the XML. Now, a problem I have is that I don't know what XML libraries you've used in Java, if any. But basically, all of these down the left-hand side, such as Tracks, DOM4J, XOM, and OXM, are all different frameworks for working with XML. Now, only the first 3 of them are enabled by default, but the others are enabled if you add a jar file to your class path. Now, what I've decided to do for this video is I'm going to show you how to work with 2 of them. I'm going to use JDOM first of all. Now, JDOM is a Java library that gives you very fine-grained control over the XML. You can access every single tag individually, and you can really do what you want with the data. It's tedious, relatively simple, but you do get full control. So that's why JDOM was one of the additional jar files I gave you for this chapter. But then we'll go on and we'll write an endpoint using JAXB, JAXB2. Now, JAXB2 is a really interesting one. In fact, JAXB will take an XML document and will create a Java object from the XML. And actually, it's exactly the technique used by JAXWS. So in all of the previous chapters when we've been automatically getting Java objects, it's been using JAXB under the hood. Now, it may seem daft that we're now using Spring WS and yet we're reverting back to automatically generating objects from the XML, but once again, I know I've said this, but it's worth underlining. The point is we can choose any of these different approaches for each of the methods on our web service. So it might be that we use JAXB for all of the easy operations, but for the ones that are causing us problems, we can switch down to JDOM. I'll start by opening up the existing endpoint that I wrote in previous chapters. Now, if you've not done the chapters on JAXWS and you've come straight to this chapter, then don't panic. All you'll need to do is create a new class called Customer Endpoint and add it to a package. It can be called anything you want, but mine was called webservices. And the reason you don't need to worry is that I'm going to take this class and I'm going to pretty much remove everything from it. The web service annotation comes from JAXWS, so we won't be wanting that anymore. And in this chapter, I'm only going to be implementing one method on the endpoint. So I'm going to take away the implements customer management service. For this chapter, all I'm going to be working on is the method called find customer by ID. So I'm going to remove every other method from this class. You can also remove the set service method for reasons that I'll explain in a few moments. Now, because I'm not implementing the interface anymore, I can remove the @override, and I'm also going to remove the entire implementation of that method. So we really are starting from pretty much 0 on this endpoint. Now, the first rule is that an endpoint, you're probably not surprised to discover, needs to be annotated. But the annotation this time is @endpoint. And this annotation comes from the org.springframework.ws. Now that's crucial. That means Spring WS. You don't need any further parameters or properties into the endpoint annotation. Now we're going to be wiring up this bean using auto wiring. There are other ways of doing that, but it's really the easiest and simplest way of working with Spring WS. And of course, we can still use XML for the rest of our wiring, but it's going to be auto wiring for the endpoint. So you're going to need to add the @auto wired annotation to the declaration of your service object. Now, the way that we associate the methods in this endpoint with the URLs is via an annotation. And the annotation is payload route. Now, I know that sounds a little bit of a jargony annotation, but what it's saying is that effectively the incoming data to this method is going to be an XML document. By payload, they mean the XML document. And with this annotation, we're asking Spring WS to convert the very raw XML into a Java object that we can handle. Now, there are two parameters to the payload route annotation. They're both a little routine. The first one is the namespace property. Now, the namespace property just needs to match the namespace that we declared in our XSD. So we can very easily copy and paste that across. So it's the string here. Now, it needs that because if you don't give it the namespace, it won't be able to find the tags that are forming the incoming message. And the second parameter is called local part. And to understand local part, you've got to think about the structure of the incoming XML message that we're expecting. For us, the incoming message is going to look something like this. It's exactly as we defined it in the XSD. We're going to have an outer tag called getCustomerByIdRequest and an inner tag containing the data. For this incoming message, the data is very basic. It's just the ID. All the local part is effectively saying is what is the root of this message. The root tag is getCustomerByIdRequest. So that's the value that we're looking for in this field. So that's going to be getCustomerByIdRequest. So that's it for the annotation. You will need to import it. And once you've imported it, it's always worth checking. You can see there that is coming from Spring WS. Now we need to revisit the signature of this method. Because we're using JDOM, we're no longer going to be receiving regular Java objects as the inputs and outputs to this method. Instead, we're going to be receiving what's called an element. So I'm going to call this incoming, and I'm going to change the return type of the method to element as well. Element is a JDOM object, and it represents an element in an XML document. So we could have an element for the getCustomerByIdRequest tag and its contents, or an element could represent the ID element of the XML document. In other words, element is an object that allows us to manipulate the XML. The incoming element we're expecting to contain just the ID tag. But the outgoing return element is going to be a full XML document representing the entire customer. Now, the problem is I think I didn't add JDOM to the build path when I was bringing the jar files in. If I do a Control-Shift and O, you'll notice it depends what you have on your class path, but usually you'll have a lot of different element classes from a lot of different libraries. And what you're looking for in this heap is a JDOM package. Now be careful, there is one there called DOM4J. Actually, that's a completely different XML library. I don't think we have JDOM in that list at all. And that'll be because if I go back to my lib folder and find the JDOM jar file, there it is. It's not on the build path at the minute. So right click, build path, add to build path. Then back to the endpoint class. Now Control-Shift and O again. And this time, yeah, there's more of them there. That's the one we're looking for, org.jdom2.element. So I'll click finish there, and there's the import, and that's now looking good. So we've got an XML document coming in, and we can return an XML document back. By the way, once we've set up the types, you can actually call the method anything you want. So this could be fetch the customer details JDOM version. the method name is completely irrelevant because it's going to tie this method to the getCustomerById request. So it really doesn't matter what the Java method's called, and I'm going to call it JDOM version just so that we can create another version later on in the chapter. So what we're going to do in here, well, there's no easy way of saying this. Working with JDOM is powerful, gives us very fine-grained control, but it's really quite tedious. For example, we've got the incoming XML document here, and I need to retrieve the ID from it. How do I do that? The incoming object is effectively the XML document you can see here. Now, the outer tag is getCustomerById request. We don't actually need that. What we need to do is get the details from the ID tag. Now, that's a child of the incoming element. So we're going to have to navigate the graph of XML elements. And one way of doing that is by calling the getChild method on the incoming element. And I can specify the name of the element that I want to request. Now that's going to give me, in turn, a new element, which I'm going to call ID element. So going back to the caption, that's effectively extracted the element here. But it's still in the form of a JDOM element object. I ultimately need a string. I'm going to call that string ID. Now to get the text from an element, you call the element object, and there is a getText method. So that is going to extract the text, in this case 100029, from the ID tag. So quite hard work that, 2 lines of code just to get the ID that we need. Well, at least the next part's going to be pretty simple, because now we have the ID, we can call our service, and we can call the findCustomerById method, passing in that ID. And that's going to return us a regular Java customer object. Okay, now I need to import the customer class. So that's done. Now that method might throw a customer not found exception. We'll come back and think about how to handle exceptions properly in a short while, but for now I'll just ignore the possibility of the exception. Now, once we've found the customer object, all we've got to do is build an XML object representing the customer. So that job's going to be fairly routine. We're wanting an XML document that looks something like this. Notice we do have to build the full document, including the getCustomerById response tag, followed by a nested customer tag, and then all of the data nested inside it. Now, this is not an XML course, and I don't know if you've used a library like JDOM before, so I hope you don't find this too boring. I'm just going to code out how you build an XML document using JDOM, and I'll try to explain anything that's a bit tricky or complicated. If you already know JDOM, you can safely forward wind through this short coding section. So we need to build a new XML document. So we're going to do that by constructing a new element. And this is going to be the, I think the outgoing element. This is going to be the element that we're going to return. And you simply instantiate the new element. And you pass in to the constructor of that element the name of the outermost tag. So that's going to be getCustomerById response. Now, one tricky bit is that we do need to add a namespace to this outgoing document. Otherwise, the receiving client won't be able to find any of the tags. So the way we do that is by calling a method on the outgoing object called addNamespaceDeclaration. Now, you might have been expecting that we can just type in this string that we have here, but unfortunately we can't, because it's expecting an object of type namespace. The way you create that object is by calling a method on the namespace class called getNamespace, and that enables you to specify 2 parameters. The first parameter is the prefix for the namespace, which I have as TNS, and then the second parameter is the full name of the namespace. And I'll need 2 round brackets at the end to close it. So that's a little bit awkward, and notice that we've now got a repetition of this exact string. So if you're working with JDOM in an endpoint, you'll almost certainly want to highlight one of them, right-click, refactor, and extract constant. And I'll just call this constant the namespace. And that will make that a constant in the class and will replace the 2 references to that string with that constant name. I often forget to add the namespace and it causes all kinds of problems. The rest of the work now really is just fairly routine in building up the XML document. We're going to need an element for the customer, so I'll create a new element called customer. And as before, we pass into the constructor the name of the tag. So I've now created this tag here and this tag here. I now need to create some nested tags for the actual data, customer ID and company name and so on. So I'm going to need an element for the customer ID called customer ID. I'm going to need an element for the company name, and these values here must match what's in the XSD. There'll be an element for the email, and there's telephone and notes as well, but I'm going to omit those because I realize that this is getting a little bit boring for you. But for each of these elements now, let's take the customer ID element. That's the tag here. I need to set some text for that tag. In this case, 10029, the actual value for the customer ID. Now that's quite simple to do. We call on the customer ID object the setText method. And the value for that text is going to be whatever was in the found customer, and we'll call getCustomerID. And we'll need to repeat that for the company name and for the email. So that's all very well, but all I've done here is I've now created each of the individual tags, but I haven't built the structure. I need to connect these tags together in a hierarchy. So, for example, I need to take the customer tag and I need to add to the customer tag the customer ID element. So that's the add content method. Will allow me to take any of the elements and add them as a child element. So I'll need to do the same with the company name and the email. That's now built up the full customer tag. The final step is to add that customer tag as a child element to the outgoing element, which of course is the outer tag called getCustomerByID response. Now, I could have done this in slightly fewer lines of code, but I wanted to do it longhand first just to show you all of the admittedly tedious steps. But I could have effectively combined these 3 separate blocks into a single line of code. So for example, after I've created the customer element, I could add the full customer ID element to it by, and it is going to be a long line of code, but I can take the outer customer tag, call add content, and the content is going to be a new element called customer ID, and then I'm immediately going to call setText, and the text is going to be the result of the found customers getCustomerID method. This one line of code here has replaced this line, and this line, which makes it slightly less unwieldy, I guess. Now, off camera, I'm going to pause the video now and I'm going to refactor company name and email to make them similarly single lines of code. So these aren't the most elegant lines of code, but I think it's slightly tidier than the previous version. Since I'm here, I may as well add in that if the found customer has a telephone, so I'll say if that's not equal to null, then we'll add that content. I think it's called telephone in the XSD, and we'll be setting the text of that to be the telephone of the found object. It's always awkward getting the right number of brackets there, and I'll do the same for the final optional field, which is the notes. Did you enjoy watching that? I'm sure you didn't. You probably enjoyed it as much as I enjoyed recording it. The point of all that is we've now created in memory an XML document representing the structure you can see here. And now, by returning that object, because Spring WS knows to expect an element in return, it will now deal with converting that into a proper XML string, which it will send back to the client. This is hard work. There's absolutely no way of hiding that, but it's kind of the point. We've got complete control over the structure of the XML here. In real life, I probably wouldn't have used JDOM to do this particular example because there was really nothing complicated in the XML anyway. It wasn't worth doing it by hand, but you might have some situations where it would be useful. Now, just before we move on, I've just realized in comparing this with my rehearsal copy that I have missed one annotation from this. You do need an annotation here on the incoming parameter, and that annotation is effectively there to tell Spring WS that it is an object that we want it to create as a result of the incoming payload. The annotation is very simple. It's just @request payload, which of course we'll need importing, and as usual that comes from the Spring WS package. Now we'll come back to this endpoint when we've got everything working, and we'll create an alternative version where we use a higher level API to generate the return XML document. But for now, this is a good enough endpoint. All that remains is to do a little bit of configuration to make all of this come together. Well, as usual, we're going to need to configure a servlet to make all of this work. And Spring WS ships with its own servlet that is designed to deal with these incoming requests. The servlet's called the Message Dispatcher servlet. Don't confuse this with the Spring MVC Dispatcher servlet if you're familiar with Spring MVC, but it does actually work in a very similar way to the Spring MVC Dispatcher servlet. So we need to configure this servlet, and the servlet name is going to be important. We can call it anything we like, but you need to remember this name. So I suggest you go with the same as me, which is Spring-WS. The class is, as you can see here, and there is an init parameter that we need to pass in, which is transform WSDL locations. Now you'll see the value of this in a short while. For now, if you can just accept that that parameter is needed, you'll see its effect in a very short while. For the servlet mapping, this is going to be the URL patterns that we want to associate with our web services. Now, for now, I'm just going to make all URLs coming into this web application relate to the Spring WS servlet. Now, that does mean that for a short while, we're not going to be able to access our web pages, the ones that are ending in .html that need to be handled by the dispatcher servlet. But rather like I did in a previous chapter, we'll come back and switch the dispatcher servlet, the standard one, back on when we've got all of this working. So I'm not going to bother typing this in front of you. You can either pause the video now and add this to your web.xml, or you can copy and paste it from the finished version of web.xml in the practicals and code folder for the solution folder of this chapter. But as I say, we will need to be careful to make sure that the dispatcher servlet is temporarily deactivated. So in the web.xml file, I don't know what state your current web.xml is. It depends what previous chapters you've done. But I'm going to comment out the declaration of dispatcher servlet. If you did the previous chapter, then you will have a context param block here. Now I'm going to comment that out as well because I am going to reactivate that when we come back and switch our web pages back on. And I currently have a servlet here for, it's confusing this, WS Spring servlet is actually the bridge servlet that allows JAX WS to work. So in fact, we want to get rid of that if you have it. And I'll paste in the new XML block that, as I say, you can find in the Practicals and Code folder for this particular chapter. Or you can pause the video if you prefer to type it out yourself. Now remember that the name here, this Spring WS, is of crucial importance. Now in our previous work, we had a Spring XML file, which I happen to call remotingserver.xml. And this file was responsible for taking our endpoint and associating it with a URL, and for declaring an instance of the endpoint bean. Well, we're still going to need this XML file, but it is going to be of a different format. And it's going to have a different name because this file is automatically loaded in by that new servlet that we've just configured. And what it will do, very similar to Spring MVC, this servlet will look for a file called exactly that string -servlet.xml. So for us, it's going to be Spring WS servlet.xml. So it is going to be a completely new file, this. So I suggest you take your remotingserver.xml file, if you have one, and delete it. So we need a replacement for that file, which is Spring WS servlet.xml. I realise this chapter's getting long now, and I didn't want you to have to type in yet another XML file. So in the additional jar folders, I've just added in an extra XML file called springwservlet.xml, which is exactly what you want. And if you drag that into your SRC folder and select Copy Files and click on OK, then you'll see if you open it that this is a skeleton of the structure. We will need a little bit more configuration in here. Let's talk through it. Most of it's fairly routine. First of all, I'm importing in all of the other tiers of our application. You'll be used to doing that kind of thing. And then I'm doing a component scan on the base package of our web services. So this is going to find that endpoint class. But then you need an additional directive called annotation driven. Now, I've never understood why this doesn't replace the previous tag. I suspect it's a slight oversight by the designers, but you do need this tag here. This is what tells Spring WS to go and find all of the other annotations, such as payload route. It's effectively doing all of the work of setting up the actual endpoints. Notice that this tag comes from a new namespace called SWS, and that has been declared up here in the schema declarations. But there is one last thing we need to do, and that is we need to declare our endpoint here in the XML. Now, I thought we'd better type this in, otherwise it will all be a little bit too magical. Let's have a look at what that's going to look like on a caption. The tag that we're using here is the dynamic WSDL tag, again from the SWS namespace. What this tag does is it tells Spring WS that we've written an XSD, but we want Spring WS to convert that XSD into a more complex WSDL. So all you can see here are all the parameters it needs to do that. First of all, we have an ID. Now, technically, that's just a standalone label, but actually it is important because the ID that we use here will become the URL of the WSDL. It automatically generates a WSDL and it gives it the name customers.wsdl. So remember the string that we use here. For port type name, we're just here defining what we want the name of the web service to be, and that's the name that clients are going to see. For location URI, that's just the address that we want the web service to be published at. Not the WSDL, but the actual web service. So this is telling a client what URL they have to access in order to be able to send data to the web service. So that's just a / followed by any meaningful string, but oftentimes we just use the same name here as we use for the port type name. The target namespace is just the same namespace that we used in the XSD. And then finally, we have a nested tag. The nested tag is SWS:XSD, and this is just pointing to the XSD that we've written. Now, it's common practice to store this XSD in the webinf directory of our WAR file. Now, I don't know if you're familiar with that approach, but that effectively makes it a private file. It will prevent any users of our web application from accidentally accessing that XSD file. Now, we're going to have to make sure that the XSD is actually put in the webinf as part of our build, but that's going to be easy to do. So I hope you can see from this that there's nothing very complicated in here. Let's get that into Eclipse. So we're using the SWS dynamic WSDL tag, and very helpfully the editor has added most of the parameters here. So the ID is going to be customers, and that's important to remember it. The port type is really the name of the web service, which I'm going to call customer service. The location URI will be the same again, but with a / in front this time. And the one field it's not added in is target namespace, which needs to be the same string that we had in the XSD. That's all okay. And then we have a nested tag. It's look a little bit ugly, this, but the nested tag is SWS:XSD, and the location is going to be /webinf / and then whatever the name of our XSD is, which is CRM schema.xsd. Well, that's all of the major elements of the configuration out of the way. Just one minor thing to do is we need to make sure this XSD file is actually in the webinf directory when we build the jar file. So this isn't an ANT course, so I'll keep it simple. In the build.xml file, if you scroll down, you'll find somewhere in there the target called WAR, and you'll find a tag here called added for Spring MVC. And what this line is doing is it's saying that all XML files found in the src directory should be transferred to the webinf directory. Well, we want the same thing here. So I'm going to copy, in fact, I will literally copy that block there and just change it to say that we also want all files ending in XSD in the source directory need to be transferred into the webinf folder of the WAR file. Now, if you wanted to, you could have created a separate folder to hold the schema, and you would have just changed the folder name there. But that should be enough for us. I think at last, that was really hard work. We can now get this deployed. So start up Tomcat if you haven't done so already, and then run your build. Now, of course, we've done an awful lot of work in this chapter, so don't be surprised if you get stack traces or compile errors. I am coding live myself, so I'm fully expecting to see errors myself. I'll be amazed if this works for the first time. So obviously the first thing to do is check there are no exceptions here in the Tomcat log. It looks as though that's starting up okay. If I go back to a web browser, I have my all customers page that I happened to load up earlier, but of course now if I try that URL, I'm expecting to see, I was kind of expecting a 404, but I'm actually getting a 405 because it's saying this HTTP method is not allowed for the requested resource. And it's saying that because we've done the URL mapping for all URLs to go to the Spring WS servlet, it's interpreting this as a call to a web service, albeit one that doesn't exist. And Spring WS is saying, look, you can't make GET requests on that particular address. So hopefully when we've restored the dispatcher servlet, that will be working again. But what we can try to do is to access our WSDL. Now the WSDL is going to be published at the address localhost 8080 / my web app is the context root, and then it will be whatever the ID you used in the config file here was. So that ID was customers followed by .wsdl. Well, I'm going to hold my breath here, and well, I'm absolutely amazed that worked. I am seeing something resembling the mess of a WSDL, and let's just have a look and make sure that everything's in place. I hope you're seeing the same thing. If not, then go back through the video and check each of the 4 major steps in turn. But I can see in here we have a schema declaration, which has got my response and request defined, and there's my customer type. But now here's the bit that Spring WS has generated for us. It's recognized, because I've used the word request and response, it's recognized that it needs to generate a WSDL message for each of them, and then a port type with an operation for get customer by ID. And notice here, this is quite crucial. The SOAP address is the URL that clients have to call in order to send data to this web service. And notice that that URL is localhost 8080 my web app followed by the name that we specified here in the configuration under location URI. Now, the reason it's been able to generate full URL reflecting the name of the server this has been deployed to is a result of that init parameter that we passed in of transform WSDL locations. If you didn't have that in place, then the URL appearing here would just be / customer service, which is no use to clients at all. So it looks like we have a WSDL. So all that remains now is to see if we can build a client application. Now, we did build a SOAP client in an earlier chapter, but that web version was using the Spring support for building clients, which you might remember I wasn't particularly keen on. So I think what I'm going to do for this chapter is I'm going to close that SOAP client. In fact, I'll delete it from the project just by selecting delete. I won't tick delete project contents on disk. I'm going to create a brand new project just to emphasize this is completely clean and fresh. So this is going to be client for Spring WS version. I can call it anything really. And I'll close all of the tabs in the editor here so they don't get in the way. Now, you should know from previous chapters how to build a basic client. I'm going to use JAX WS to do this because I think it's fine to do that on the client. And I'm going to use the WS import tools before. So if you don't know what I'm talking about here, then you will need to review the chapter where we overview JAX WS. Now, on this particular workspace, I don't have an external tool already created. You might be able to just modify your existing one. I'll need to select Program here and New Launch Configuration. The location we'll find in the JDK directory, WS Import Tool. The working directory will be in the workspace. That's going to be the folder for the project. And the arguments will be -keep, -verbose, -s, ./src, -d will be the destination directory, that's bin, and then we need the URL of the WSDL, which will be the same URL we used there. So hopefully that's enough, and I can now click on Run. Now remember, you will need to run this step every single time you make a change to your program on the server which is going to affect the WSDL. So if you change the XSD, for example, you'll need to rerun WS import. But that's generated all of the classes representing the service. Now, the big difference this time around is that you are going to have to work with the request and response objects. You won't get customer objects directly. So allow me to demonstrate that. I'll create a new class I won't put this one in a package just to keep it separate. And I'm going to call the class main, and I'll generate a public static void main method. And the steps as before, we need to get hold of a customer service object. That name has been generated from the name of the web service port. And I'll call that service. And as usual, we use that factory class, which is called rather ugly customer service. We create a new instance of that and then call the get method on it. I will need to import all of these before I call that get method. The get method has a rather odd name this time around, and it's because the generator has given the port name a rather ugly port name, which is SOAP 11. It actually stands for 1.1. It's a SOAP version 1.1 web service. Now, in a short while, we are going to take control of the WSDL, so we could, if we wanted to, give that a much friendlier name. But for now, that's the unpleasantness out of the way. I can now call on the service, get customer by ID. But as I said, this is the difficulty. You might have been expecting just an ID in there, but actually the parameter is a get customer by ID request. Now that's an object representing the entire XML document, and I do have to create a get customer by ID request object. And once I've created that object, I will need to call a set method on it, which allows me to set the ID. Now the ID, the usual 100029, which I know exists in the database, and that will enable me to call the service. Now this get customer by ID method is going to return an object of type, you've probably guessed, get customer by ID response. And I'll call that response and import that class. And then it's very routine now. On the response, I can call get customer, and then I can drill deeper down into things such as the company name. So I'm just going to do a system out print line on that company name. Now, of course, we're expecting Acme from this. I don't know. Let's see what happens. Oh, bad news. It's an exception. Let's have a look at the full detail of the exception. It's saying no adapter for endpoint. And then it has a reference to our method name, fetch the customer details. It's one of those it's one of those exceptions with a lot of English in. Is your endpoint annotated with endpoint, or does it implement a supported interface? Now, like we can answer the first question. We did put at endpoint on our endpoint, but the rest of the question is saying effectively, does it have the correct structure of an endpoint? Have you correctly defined an endpoint? Well, I can tell you that I had to pause the recording there to try to work out what I've done wrong with the endpoint. So I'm very sorry about that. But if you go back to your server project and find your endpoint class, I've discovered that I did miss one crucial element from the endpoint. And it's here where we specified payload route. Now, payload route on its own is not sufficient if we're returning data. This would have been okay if this was a void method, but it's not a void method, it's returning data. And we have to warn Spring WS that we're going to be returning data by adding an annotation. It's a very simple one, which is at response payload. It's effectively, of course, you'll need to import that. It's effectively the opposite of the request payload. This is warning Spring WS that there's going to be incoming data that it needs to translate. This is warning it that there's going to be outgoing data that it also needs to translate. I'm kind of glad that we had that error in a way, because it does alert you to this exception, which you will see a lot of. And you kind of immediately know this means there's something wrong with the structure of your endpoint class. And you'll need to make sure that all of the annotations are in place. So I'm going to need to rerun the build. Now, because I haven't changed the schema, I don't think I need to regenerate the the classes with WS import. So we'll just redeploy that. And there it goes. It's worth just checking that the WSDL is still live. And it is. The page is still responding. So I can go back to my client now. And let's give this another try. And that's excellent. We're now getting some response data. Now, I did say a little bit tongue-in-cheek that I've had 6 rehearsals of this chapter while recording, and I have, and it's taken me that much pain to get to the point where I'm getting a clean run. So please, if you're having problems right now, don't be disheartened. Just check every step along the way. It only takes a small slip to get quite confusing errors. Spend some time working on it, and if you're completely frustrated and completely stuck, then of course you can send in a support call. We understand this is difficult, but it's certainly worth spending a few hours, even if it's frustrating hours, getting this up and running. Well, that was quite grueling, but the point of Spring WS is that it's an extension project only for those who need it. Many projects can just use the built-in core JAX WS support. But if you're wanting to follow the contract-first development path, then Spring WS gives you the tools. I've only shown you JDOM so far, and yes, it was hard work, but do remember, you would only do this fine-grained coding if you need it for a particular operation. You might only need it for 1 or 2 methods. For the rest of the methods, you can use a higher level XML library, and we'll be doing that and more in the next chapter.